we're going to take some time on doing that. So for solving quadratic equations, this is kind of a subset of what you've already learned about factoring and finding the roots of equations. And so when we have a polynomial like this, one of the most direct ways to solve it is just simply by factoring. So you know how to do this. You take 54 is positive, so we're looking at the same sign. Negative 15 means that they're both negative. And so what factors make 54 that add up to 15? And that would be 9 and 6. And so we put in the right negative, and so we get x equals 6 or x equals 9. This should be pretty standard for you now. Let's say we have something like this. Of course, we have to put it first in standard form. So it'll be x squared minus 7x minus 18 equals 0. There again, we factor it. We know that they're going to have opposite signs. They have to add to 7. The larger one is negative, so we have x minus 9 times x plus 2, and our solution then is 9, or x equals negative 2. Now you know, not everything factors, so this is a good way to do it when you're dealing with small numbers that are easily factored. We can also use the square root property that we've been using in the last section. And so if we have something like this, u squared equals d, then the square root of u squared equals the square root of d. If that's exact. But then we have to pay attention to one thing here, and that it's not u equals the square root of d, it's the absolute value of u equals the square root of d. Remember, in this original equation, u can be negative, and then we get a positive d, right? So if we have the square root of d, that's going to be positive, but if it's negative, we have to take the absolute value of it. So in other words, if u squared equals 9, then the absolute value of u equals 3, so u equals positive 3 or negative 3. Okay, so remember, when we're going to use the square root like this, we have to keep track of the absolute value sign so we get both solutions. And so we can write it like this, or you can use the plus or minus sign if you like. Okay, so in general, with a polynomial, you can have up to as many solutions as you have the degree of the polynomial. So with a quadratic equation, the degree is 2, so you can have up to 2 solutions. If we have a cubic equation where 3 is the highest exponent in that, you can have up to 3. Now you may have 1, 2, or 3, or with a quadratic equation you may have 0 or 1 or 2, but you will not ever have more than 2. So you have, whatever process you use, you have to account for the fact that you may have 2. Okay, so we look at this. 4x squared equals 20, and if we do it the old way, okay, we're going to say 4x squared minus 20 equals 0, and then we can factor out a 4, and we get x squared minus 5 equals 0, right? Now that doesn't factor, not to integers anyway. So let's use the square root property and see what happens here. So I'm going to take x squared equals 20 over 4, x squared equals 5, take the square root, and I get plus or minus the square root of 5. Okay, so the square root property here will give us an answer regardless if it's an integer or an irrational number. If we have something of this form, we have two choices. We can expand that x minus 3 squared and then subtract 7 from it, see if it factors and come up with our solution there. Or we can add 7 to both sides and then take the square root, and we get x minus 3 equals plus or minus the square root of 7. That's not our answer. We're trying to solve for x. So we add 3 to both sides and we get 3 plus or minus the square root of 7. Now for a lot of you, this perhaps is going to start to look familiar because you remember the quadratic formula. That's that thing that's x equals minus b plus or minus the square root of b squared minus 4ac over 2a, right? You've all seen that. And you get that you get that number plus or minus a radical, sometimes divided by 2 or some other number. And so the form here is going to start looking familiar. And in fact, when we're learning how to complete the square, I'll do that with coefficients in general, and we'll actually get the quadratic formula. Okay, so you use the square root property on these 4 here. Try that. And then I'd like, let's see, Catherine, will you do the first one on the board? And then Miles, will you do the second one?
Is that the one with 45?
Second one would be the, horizontal. 25x squared equals 16. Luke, why don't you do the third one? And Ivan, why don't you do the fourth one, okay? Oh, hang on here. Just want to make sure this gets in the recording. I didn't resume the recording after I paused, so it'll just be there now. Okay, so now we're going to talk about equations that are in quadratic form. These aren't necessarily quadratic equations, but we can put them in quadratic form, find the solution to equations that would otherwise be very difficult for us to solve. So what we're going to do is something called U substitution. And you're going to see this a lot in calculus, where you have U stands for something other than a simple variable. Now, if I look at this, I can say, okay, this is quadratic form when U is in some form of x. And so let's say we have this equation, x to the 4th minus 5x squared plus 4 equals 0. Definitely not a quadratic equation because we have a 4th degree in there. Okay, so let's put this in quadratic form. So we're going to do this by substitution. I'm going to define u equals x squared. So then if u equals x squared, I'm going to get u squared equals x to the 4th. And so if I make my substitutions for the x to the 4th and x squared with my new definitions of u, what I get is an equation that is u squared minus 5u plus 4. Okay, so now here's an equation that you could solve, because now this is a quadratic equation. You've put the original equation into quadratic form. And so we get this by factoring. And so by the zero product principle, either u minus 4 equals 0 or u minus 1 equals 0. Now your answer is not u equals 4 or u equals 1, because I don't care about u. You invented u here. I'm really interested in x. And so we'll put x back into the equation, and x squared equals u, and lo and behold, what do we have? We have x squared minus 4 equals 0, x squared minus 1 equals 0, and so when we solve those by factoring, we now have 4 solutions. We have x equals 2, -2, 1, or -1. So this is consistent with what I just said a few minutes ago about when we have an equation that's x to the 4th, we may have up to 4 solutions. And indeed, we do have 4 solutions here. Even though we put it in quadratic form, which has 2 solutions, when you go back and you resubstitute your x squared for your u, you go back and clean this thing up to get x rather than u, you're going to find that you actually do get 4 solutions. Okay, so let me give a few more examples. And sometimes this is difficult for people, so I'm going to cover this again on Monday, okay? But bear with me here. Now here's how you look at these. Here's an equation that it has 2 instances of x in there, right? It has x and it has the square root of x. Now if you compare the two, you know that one of them is the square of the other. So if we take the square root of x squared is x. And so what we can do is I can define u to be the square root of x, and u squared equals x. So let me substitute where I have an x, I'm going to put a u squared, and where I substitute, where I have a square root of x, I'm going to put a u, and I get this equation here. Now this is a quadratic equation. So we get this by factoring. And so we have u minus 6 equals 0, or u plus 1 equals 0. Now let's go back and let's put in our expression for x instead of having u. So I look at here and I say, oh, I want something that's x, not u. So I look up here and I say, okay, u is actually the square root of x. So I'm going to put that in my equations and solve for that. Okay, so here's one that when you're dealing with square roots you have to check, okay? Look at what happens here. U plus 1 equals 0. Put the square root of x plus 1 equals 0. The square root of x is always 0 or more, and so there's no value of x that will give me a negative square root, so there's no solution. So I don't have a solution to this part, but I do have to check this other one. Does 36 work? Okay, 36 minus 5 times the square root of 36 minus 6 equals 0, and all that checks out. Okay, a couple more examples, and I'll probably give one. We'll probably just finish this chart, and then we'll go back to it on Monday again. Here we have 2x to the 2/3 plus x plus 5x to the 1/3 minus 3 equals 0. Now the key thing to look at is that is the exponents in x. If I take x to the 1/3 and square it, I get x to the 2/3, right? Okay, so that's my substitution. I can say x to the 1/3 equals u, and that makes x to the 2/3 u squared, and I can put that back into my equation just the way I've defined u. Now from here, I can factor this. I won't go over all the factoring steps. I'm confident all of you know how to factor that. But now that I have these two expressions, I know that one of them, one or the other one has to be 0. And so when I solve for u, I get 1/2. And so x to the 1/3 has to be 1/2. So x equals 1/2 cubed, which means 1/8. So if I go to the other side now, u equals negative 3. So x to the 1/3 equals negative 3. I'm not having an issue with negatives here because 1/3 is the cube root, and we can take the cube root of 3, or of a negative number, so I'm going to cube both sides, and I get x equals negative 27. Now there's two really different answers, right? You got 1/8 and negative 27. Now, you can put that in there, and you can see, you can try those two values. I didn't do that explicitly on this chart, but they both work, and so they're both solutions.